around the y-axis. 5x squared, 5x, x greater than or equal to 0, about the y-axis. So let me at least pull a picture up. Ooh, that did not like that. Yes it does. Yes it does. One's a parabola. And the other one is a straight line. And we're going about the y-axis. And so the shape we are getting is kind of like a funky cup or bowl shape. And so what we are doing, and we introduced the disc method, so what we are doing is we are cutting perpendicular to the y-axis, right? So just to remind ourselves, as our warm-up, we are using the washer method and we're cutting perpendicular to the y-axis. So just remind ourselves, we're talking about the washer method. So all the cuts we make go perpendicular to the y-axis. And because there's a hole, what we're pulling out is washers, and every washer has two radiuses, a big one and a small one. And so I'm just making sure you guys are all getting set up the right way, right? You have a washer, and you're going to be focusing on two radiuses. The big one for the big circle, and the little one for the little circle. And just to do one more review, because I know it was a long weekend. Well, a weekend, and weekends tend to be long. We're taking the big radius squared, we're finding the area of the bigger circle, and then we're subtracting the area of the smaller circle. So just to remind and review everything we talked about on Friday. So if I translate that all up here, got my big circle, which is the one that's created by doing the outermost region or the outermost curve. And I've got my little circle, which is created with the innermost curve. And R is always measured from your axis of rotation. So I will write that down. Your R value, always measured from your axis of rotation. Guys doing okay? You guys feeling okay so far? So the very first thing that we like to do is we like to say, are we going dx or dy, right? And we already said it's going to be dy because we are cutting perpendicular to the y-axis. So our slices are going to be perpendicular to the y-axis. So that creates those thicknesses, dy, delta y. Got me limits, Munia, got me limits? 0 to 5, absolutely. They've got to be y value limits, right? Just so you know, your limits always have to match your variable of integration. Then we've got pi, and then inside it's going to be big R minus little r. And while we're at it, I just want to add the extra note. Because we're doing dy, we want to solve our equations in terms of x, right? Solve our equations for x. So I might as well do that while we're at it. So that means x equals y over 5. And x equals y over 5 in a square root. Plus or minus, but we're on the positive side. So I'm just going to do the one on the positive side because the negative one is on the other side. Do you guys put this all together? Come up with an answer? Let's see. So, let's see. Volume equals 0 to 5 pi. Anyone tell me big radius? What'd you guys get? What'd you get, Alex? Root y over 5. Squared, right? Big radius squared. Minus the other one, y over 5 squared. You guys are good. The calculation might be a little tricky just because you have the 25, so I'm just going to pull pi out. And then we've got, what is that? Square, this is just y over 25 minus y squared over 25. And then you take the antiderivative. Oh.
5 is also under the square root.
Oh, 5 is also under the square root. Thank you, thank you, thank you. 5 is also under the square root. Y over 5. You get y squared over 10 minus, what is that, y cubed over 75. Going from 0 to 5. So that's pi times 25 over 10 minus, 25 times 5. 125 over 75, but I think I can reduce those down a little bit. Pi times, what's that, 5 over 2 minus, what's that, 25 goes in there, 3. Nope, Tina, that's wrong. That's wrong. Hang on a second. 5 times 5 is 25 times 5 is 125 over 75. Is it over 75? Ah, yes. Wait, okay, Tina, so what goes in? Why is my brain just having a fritz right now? 5/3. Thank you. 25. Holy moly!
Yeah.
I did sleep last night. I did. But I did take NyQuil, and NyQuil, whew, I had to take NyQuil to knock me out there. We getting 5/6? Everybody getting 5/6 pi cubic units as our warm-up? If not, give a holler. That is, let's take then, now that we've got disc and washer method down, and we've practiced some problems with that, I want to take, can you guys see can you see this? Is it too small? I'll make it a little bigger. But what we're going to do is we're going to use the disc and washer method to find the volume of a solid obtained by rotating regions that are around curves that are not the x-axis and the y-axis. Here, let me get this down a little bit, see if this helps. I don't know if that helps at all. Maybe that helps more. That might help more. Put this up a little bit. All right, so y equals 4x to the 4th, y equals 4, and we're going to send this region about the line y equals 6, okay? So first step is we have to get a picture of what's going on. So we're going to practice, first of all, getting that region. And as I've mentioned before, on your test, I will give you this graph. I will give you the graph. I will not rotate it. You'll have to rotate it. I will not give you anything else. You will be responsible for everything else. But I will give you the graph. Y equals 4x to the 4th is very much like y equals 4x squared. It's a parabolic shape, except it's just a little flatter U. It's kind of like a little flatter on its bottom, and then it goes steep, okay? So y equals 4x to the 4th is kind of like a parabolic function. So let's draw him in. Now, it doesn't say x has to be greater than 0, so I'm going to go both sides. So 1 will map to 4. And I also know that 1/4, nope, 1/2 Nope. Oh, 1/2 to the 4th is 1/16, so that's like at a quarter. Okay, so that kind of helps me a little bit. X is 1, X is 2. So I have y equals x to the 4th. Oh, Tina, you did that bad. Because I have to revolve it around y equals 6. Scratch that sucker. All right, let's try that again. Think before you draw. Think before you draw. Let's try that one more time. 1, 2, 3, 4, 5, 6. Ooh, that's also not going to work. One more time. Oh my God, Tina. Hopefully your pictures are way better than my pictures. 1, 2, 3, 4, 5. That'll work. Going about the line y equals 6. That's going to be my axis of rotation. So I'm going to be going about this line, y equals 6. Getting my picture. 1 maps to 4, 1/2 maps to 1/4. Okay. Yeah, Alex.
Does that mean dx?
Yeah, it will. Good call. It will. Because it's like an x-axis, right? It's like an x-axis. So I'll just write this down. Y equals 6 is like an x-axis. Beautiful. So you are going to cut perpendicular to the x-axis. Which means you are going to have dx, right? Our slices are going to be dx. Y equals 4 is a horizontal line. So we are taking the region that's bounded by those curves, and it's almost like a donut, isn't it? No way, it's kind of like a funky donut. Maybe a bagel, a little more like a bagel, like kind of more elongated, I'm guessing, right? So what we're going to do is we're going to take this region bounded by y equals x to the 4th and y equals 4. And this region is now going to not get sent around the x-axis. Instead, we're going to send it about this line. Can you picture taking that in space? Do you see what I'm saying? We're picking this up, and now we're rotating this in space, okay? All the way around. Can you see kind of like a bagel coming out? It's kind of like a bagel shape when you bring it around. Let me highlight it. If I bring it around, I've got like this shape going up here. See, I have a big mess up here. But then I bring it around and it goes all the way around. So it's coming around all the way. So it's kind of like a bagel, kind of like a, I don't know, whatever you want to call it. A big solid clay dough. I didn't bring my Play-Doh, huh? With the hole drilled down the middle. But we've got this big shape that's coming around. And then we've got this hole in the middle that comes straight down the back end. That's the shape we're talking about. Sometimes it's really hard to visualize these. I did not send you those links. I meant to send you those links. I need to send you those links. Kind of like a spaceship. Oh, yeah. With a hole right down the center of it. Like that's where you have the people come up. Like, what do you call it? That beam of light that comes down and then they go straight up through the middle, right? So when you're going to use a disc, well, first of all, because it's got a hole, what's it going to have? Which method? We're going to have the washer method, which means I've got a big radius and a little radius. And when I cut, I'm cutting perpendicular, right? Perpendicular to the x-axis because I'm going about like an x-axis. I'm cutting perpendicular to the x-axis. Even though I'm not cutting directly against the x-axis, I'm cutting perpendicular to the x-axis, which means my volume is going to be integrated with respect to x, and so we're going to write down, and we're going to write volume equals, and we're going to put the key pieces on this back end, right? dx, because that's the thickness for each of these slices, and my limits. Somebody give me my x limits. Yeah, Griffin. -1 to 1. We could also go 0 to 1 because of symmetry. and multiply it by 2, but I'll just stick with negative 1 to 1. Thank you, thank you, thank you. Okay, now this is the tricky part, right? Because now we have our big radius and we have our little radius. Our big radius is always measured from the axis of rotation. If my axis is here, I have to take my radius from this point here. Are you with me, everybody? And that big radius is, I know the shape goes all the way around, okay, I know it, but I want to focus on the black shape that we graphed. That's what we want to use in reference to. So we take our axis of rotation, we take our shape that's being revolved, and we start by saying from this axis to the back end of this shape, the farthest shape, that's my outer radius. Are you with me? So to get the outer radius, we go from our axis to that shaded part, but the farthest part. Do you see that, guys? So I'm going to draw in green my outer radius. Okay, so I'm going to start up here at my axis, and I'm just going to make a general cut. Here we go. Boom, all the way down to the farthest end. That is my outer radius. That corresponds to the outer radius for that washer. So let's put it into words then. What is my outer radius? My outer radius consists of this distance. Can you guys see that visually? So when we're going up and down, we measure distance by taking top minus bottom. Are you all with me? So what is this distance right here? Tally, you want to guess? 6 minus this, I know it's really close, it's not supposed to be 0, but it's minus this curve, which is,
4.
oh yeah, I did it wrong. 4x to the 4th, I've got an error on that. Let me fix that error first of all. 4x to the 4th. So yes, so my big radius is going to be 6 minus 4x to the 4th. 6 being that top function, 4x to the 4th being that bottom function. Then we go and we say, okay, we also have this hole, and that's created from that littler circle. We have this little hole here too that's being drilled, right? As we go around, this has a hole here. So to get that inner radius, we go again from our axis of rotation and we measure to that shaded region that we started with. So we take that distance to that distance, which is going to be what? 2, right? Or 6 minus 4, right? Because it's constantly 4, which is 2. But I'll write down 6 minus 4 because that's my little radius. 6 minus 4, which is 2. Does that make sense? So when you go around a line that's not an x-axis or a y-axis, the only thing that changes is where this distance is going to be. And you always take your axis, start there, and measure to the outside of the shape that's getting rotated. Whether it be horizontally or vertically, that's how it works. So now let's put this down. So what do we got here? So we've got our volume, and it equals -1 to +1 pi, -1 to +1. And what do I have in here? I have 6 minus 4x to the 4th squared minus 2 squared. And so if we wanted to work it out, so maybe we'll just work out this first one, but then just set up the next ones. Let's just work out at least one, I guess. If you're going to square a binomial, remember, this is one thought bubble here because students always forget to do this. We're going to multiply it out, right, and FOIL. So what's that give us? 36 minus 48x to the 4th plus 16x to the 8th. Is that what you guys got? Something like that? I think so. So inside we've got 36. Oh, and then we're minusing 4, but I'll just write it in. 36 minus 48x to the 4th plus 16x to the 8th minus 4. I'll do one more step, which is put those together. 36 minus 4 is 32. So what we've got is 16x to the 8th minus 48x to the 4th plus 32. I think that's what I got in my book here. I can pull out something. 4 comes out. I think 4 comes out. 16. 16 comes out. Oh yeah, let's make this easier. X. Well, I guess we don't have to. I'm always crazy. Do you guys like to pull out numbers or no? So let me pull out a 16. And then I'm left with x to the 8 minus 3x to the 4th plus 36 times 4. Oh, 36 minus 4 is 32. So that's going to leave me with 2. Okay. All right, Tina, here you go. Antiderivative. Antiderivative is going to be 16. Ooh, let's just put him out with the pi. Da-dee-da-dee-da. I really do always work in pencil. 1/9 x to the 9th minus x to the 4th plus 2x. Nope. Try that again, Tina. Try that again. Wrong. Fix that sucker in the middle. Okay. 1/9 x to the 9th minus 3/5. 3/5 x to the 5th plus 2x. Plus 2x. 1/9 minus 3/5 plus 2 plus 1/9 minus 3/5 plus 2. We're only working out one of these today. I'm not going to work out all these. So that's 4 2/9 minus 6/5, which is going to give us 16 pi times 4 times 45 is 180 plus 10 minus 54 all over 45. 190. Did I make that right? Are you guys getting the same number I'm getting here? Somebody please check my work. I think I'm messing this all up. I get 136 over 45. Oops. Yeah. Is that what you got? Times 16. Did anybody times 16 and have a calculator? Give me a big number, Daniel. What are you getting?
2176.
2176 pi over? We are only doing that one. We are not working any more out. Okay, here we go. Hold on to your hat. I've got y equals x squared, x equals y squared, about the line, x equals -7. Y equals x squared, x equals y squared, about the line, x equals -7. And like I said, feel free to get some sugar. If you guys want some donuts, if you want to get, help yourselves, please. Help yourselves, please. Here we go. Y equals x squared is a regular parabola. X equals y squared is a sideways parabola. I want you to draw the regular parabola. I want you to draw the sideways parabola. And then send that sucker around the line. X equals -7, which is like a y-axis. So that's going to be dy, I think, because you're going to be slicing perpendicular to the y-axis. You guys got decimals open? Got pictures going? Pictures? No way! Your Inspire actually rotates it? Oh, that's neat. Yeah, that little piece that's in there. That little piece calculators did that. I think, well, I don't know if Desmos is that advanced yet. They just started getting 3D in Desmos. I need to start making these in GeoGebra for you guys. I need to start getting this creative and getting some pictures. Oh yeah. But it's good for us to all practice this, right? Practice. Look, oh, look at that little thing. So then it rotates. So it is going to be another funky bowl, I think. Well, no, actually, it's not a bowl because it's got big hole. Does it have a big hole? It's got a huge hole. It's got a huge hole in it. It's almost, I don't even know what shape it's looking like. I can't even think of the shape it's looking like. Maybe like some kind of a washer, like, or some kind of car part or electronic. A bracelet, like a bracelet. We got a bracelet. We got it called a bracelet. I like it. I like it. Interesting shapes. Oh, Tina, you just don't read this, do you? Okay, here we go. So I know I'm going about the line x equals -7, so I'm going to leave a lot of space. 1, 2, 3, 4, 5, 6, 7. -7. And 1. Just going to make it a little bigger. So if we blow this up, drawing 0.5 thickness, y equals x. Y equals x squared. If you're looking at it from a blow-up point, it's kind of like this little moon shape or a half moon shape or a crescent. Well, not quite a crescent because crescent's curved, but it's kind of like a moon shape. And you're going to be rotating around. Oh, yeah, like a bracelet. It's going to go all the way around and just create this big band. Are you with me? It's just this big band because it starts there, and then it comes over here, 1, 2, 3, 4, 5, 6, 7 over here, and then it does the same repeated shape, and then we connect it, right? So we've got this big bracelet kind of thing. Big gap in the middle, big hole in the middle. Big hole in the middle. 1,000%. It's like what? Y equals, oh, yes, it should. Thank you. It's y squared equal, oh, Tina, I messed it all up. Yes, I did. Undo. Erase. I'll tell you what. It is one of those days, I've decided. God, thank God I'm not taking a test today, right? Do you ever have those days when it's just like one of those days? Alrighty. Okay, let's try this one more time. It started when they gave me the wrong donuts. That's what it was. Oh my God, Tina, you just can't do this today. Let's try this one more time. We've got a parabola. Mistakes allow thinking to happen. Absolutely. And boy, am I mistaken things today. I am doing lots of thinking today. My brain is like on fire. Yes. And your big R is going to be the distance all the way to the outside, and the little r is going to be the distance all the way to the inside. And this is acting like a y-axis, even though it says x equals -7, right? It's acting like a y-axis. And therefore, we better be integrating with respect to y, just to make sure we get them set up. Our limits will be y limits, so you should be going 0 to 1. So the biggest difficulty, and I don't know how you want to do it, but if you go about a y-axis, washers and discs, dy, Going about a y-axis, dy. Cut perpendicular, dy. My outer R, my inner R. Let me see if I can figure it out. You guys nailed this. You guys understand Washer method. So when we're going side to side, it's right minus left, right? Right minus left. Which one's the bigger one? Oh, yes. Oh, wait. We have ours backwards, Dan. But it doesn't, yeah, we have ours backwards. Because the outer function is distinct, is the square, y square. Like this is the square root function, and the bigger one, which is on the outside, is the square root function. Yeah, you should be ready. No, it should be -7. Oh, let me see. Well, hang on. That's if you're coming here, right? But see this point, but not anywhere else, right? Are you with me? So I look at my functions, right? So my outer function is green. So let's make sure we got this. Our outer function here is the green one. And that's this guy right here. And the inner function here that defines that inner radius is this one, right here. And we've got this horizontal distance that we're calculating. So it's right function minus left function, right? We go from our axis of rotation. We have our region. Going from here to the outside of that region gives me right function minus left function. My right function is, ooh, I gotta fix him. Hang on, I gotta fix him. Hang on, my bad. I've got to turn him into x equals, and I've got to turn him into x equals, so my green is this one. So, oh no, you guys did it right then. I messed it up. Nate and Dan, you guys had it right. It's this function first. It's this one here. You guys had it right. I messed it up. I was my head. So it's the right function minus the left function. And then the little radius is the right function minus the left function. And so when we go to set it up, we should have square root of y plus 7 squared minus y squared plus 7 squared. We won't work it out, but I want to make sure everybody's got the correct setup. Do you guys have the correct setup? That's what's important. Your big R is going to be this green function, which is this function, which is normally x squared, but we had to rewrite it in terms of x, so that's square root of y. And the inside function normally is x equals y squared, and so that guy will be the inside function. So big R and little r. I think we're going to set up one more as practice, but questions? Last practice, and then we'll talk about our new stuff. Last practice. Y equals 4 times the natural log of x. X equals 0. Y equals 0. Y equals 2. About the line, x equals -3. I think you have a homework problem like this. Did you guys have a homework problem like this? You probably have a homework problem like this. Next time I should probably send it around the other axis. I think I'm going to fix my notes in the future and send it around the other way so that we have extra practice. Change that up in my notes for next time.
races, like the game.
Yes.
You know how they have like the little diamond above their head?
Yes.
We had one of those on the homework.
No way. Yeah, that is so cool. A Sims. Nice. Well, heck, man. That is so cool.
That one made me so angry.
Oh, no. Y equals 4 ln of x is almost like ln of x, but it gets stretched. So when you're at 3, now you're at 4. So E is 2.71, so we're about here. So this guy is a graph, and it's doing something like this. X equals 0. Y equals 0 are our axes, and y equals 2 is a horizontal line. So it looks to me like the area we're looking at, is it this piece in here, guys? Is that what you guys are getting for your region that's getting rotated? It's bounded by y equals 4 ln of x, y equals 2, x equals 0, and y equals 0. And we are sending it about this line here. Well, let me move it in a little bit so that it's a little nicer. And so this guy gets sent around here. So another funky bracelet. We're jewelry designers today. But it could also be like a washer. I'm thinking like a washer thing, like you can put a light in top. I don't know. We have some spotlight things that look like this. So just different shapes, right? Got our different shapes. So what's important though is recognizing that we are going about the line x equals -3, and the x equals -3 is a vertical line. Therefore, it acts like a y-axis. And so when I cut, I'm cutting perpendicular. Do you see what I'm saying? I'm cutting perpendicular, which means I'm going to do dy. And that also means that my circles, because I'm cutting perpendicular, my two radiuses, or radii, I don't know how you say that, radiuses, have to be with respect or moving horizontally. So my inner radius starts at that line and goes to the shape, and my outer radius starts at that line and goes to the shape. Everybody's setting up an integral. You should be solving this equation for x. That might be a little tricky. This guy's x equals 0. This guy is going to be y over 4 equals natural log of x, or e to the y over 4 equals x, right? Because you take and raise both sides to e, and that cancels with the natural log. And we are not going to integrate, although this would be fun to integrate. Did you integrate? Somebody, yeah. It's actually not too bad to integrate. It would be a good one to integrate.
Could we also do it around x equals 7 and then do this function minus that function? Like if it was like
This is actually 7 units. This is for the whole. And then it touches. So you have to do 7 units from
Okay.
with me.
Yes.
So maybe, you see what I'm saying? Yes. How are you guys? Got things for me? Got things? If you want, you can try and work it through, because it's got an E in it. You can try and work it down if you like. You know, at least make your first step and see how it goes. But Let's see when we set it up. Let's see what we get when we set this up. Volume equals integrating with respect to y means my limits are going to be what? 0 to, Megan, did you get limits on this? 0 to 2? Yep, 0 to 2 because I've got y limits. Integrating with respect to y. My big radius is that big green distance right there, which is going to be the outer function, which is this guy, minus the inner function, which is -3. So you should have e to the y over 4 minus -3 squared, pi in front, minus, and that inner radius is just 0 minus -3 squared. So really, we are taking the integral from 0 to 2 of e to the y over 2 minus plus 6e to the y over 4 plus 9 minus 9. That's it. I don't even have that plus 9 minus 9 cancels. So if I want to integrate, I'm just integrating that sucker. That is so easy. No way, that's really cool. Why is it like that? Because when we multiply these out, right, we're taking e to the y over 4 times e to the y over 4 which gives us 6e to the y. But when you multiply these right here, that's e to the y over 4 times e to the y over 4. So you have to add your exponents. That's 2y over 4, which just gives you y over 2. Ha! If we integrate, Munir, you already got an answer, don't you? What'd you get? 1/2. Nope, 2e to the y over 2. If I integrate, undo. 2e to the y over 2 plus 24e to the y over 4 from 0 to 2. What's that giving us? Pi times 2e plus 24e to the 1/2 minus 2e to the 0 minus 24e to the 0. And so when I pull that all together, I think I'm getting 2e plus 24e to the 1/2 minus 26, because those are both 1. Ta-da! Cubic units. You didn't have to work it out, but it's a cool thing to challenge and practice our brains with those e's, because you will have an e on your test, I'm telling you. You will take an e function or a natural log function, one of the two, convert it to e, and have to integrate, okay? Yeah.
Would we lose points if we forgot to put cubic limits?
Nope. I just like to put it there to remind myself I'm doing volumes. I just like to put it there.